Hey y'all, we're back for a second day and I'm out. So I have another video for you, and this video is on trigonometry word problems. Now there's really nothing to worry about here. It's a lot like the Pythagorean theorem ones, where you just have to set up the picture, label the diagram, and then it's basic solving from there out. We already have those skills that we need. So in this video, I'll work through two examples that go over specific types of word problems with some specific vocabulary, and then you'll be good to go for the rest of it. So we're going to start with something called the angle of elevation. Now, since we're working with trigonometry, I'm going to start with this word up here, SOHCAHTOA. All right, so the angle of elevation here is when we're looking up to an object, the angle of elevation is formed by an observer's line of sight and a horizontal line. All right, so the thing that we need to tell here is that elevation means that we're looking up, and so this is the angle between horizontal line and looking up at something. So our first example down here, it says Casey sights the top of an 84-foot tall lighthouse at an angle of elevation of 58 degrees. How far is he sitting from the base of the lighthouse? Okay, so we're going to start with the lighthouse. Yeah. Pretty good lighthouse so far. At the bottom of it. Yep. Now this is what some have said is the best lighthouse ever drawn. I'm not sure if that's true or not, but it's pretty good. Here's the light. Oh yeah, it's doing stuff. It's being a lighthouse. Oh, we can add some stripes in there if we want. What a nice lighthouse. Anyway, so this lighthouse is 84 feet tall. We have Casey. He's over here. What's up, Casey? Nothing. Just looking at the lighthouse. All right, cool, man. Have a good day. Casey's over here, and he's looking up at the lighthouse. So here's the line from Casey to the lighthouse. Should probably finish this triangle with a line connecting the lighthouse there. It says that he's sitting, so he's on the ground. And this angle is supposed to be 58 degrees. So there we go, there's that. And we need to find out how far Casey is from the base of the lighthouse. So I'm going to throw an X right there. All right, so now that we have the diagram drawn and Casey's still staring up at the top of that lighthouse, we can find the trig ratio that we need to use by labeling our sides O, A, and H. So notice this is definitely a right triangle. Here, the opposite side would be the 84 feet. The adjacent is X, and here's the hypotenuse that we don't need to know. So if we have O and A for the sides that we're working with and what we need to know, then we can select our trig ratio based on that. And since we need O and A, good choice would be tangent. Here we go. Tangent of 58 degrees equals, and now we set up O over A, so that would be 84 over X. What would we do next? That's right. We'd multiply both sides by X. That clears out the denominator there, and we have X times the tangent of 58 equals 84. And then divide. And that's where we get our x equals, this cancels out. We have to do 84 divided by the tangent of 58. And luckily we've got my handy dandy calculator. So I just type in there 84 divided by the tangent of 58. Close that up, hit enter. Boom. This guy Casey is 58.489 feet away. Now I think this says we're going to round to the nearest tenth. That's right. So 52.5 feet would be good. And there's your answer. So angle of elevation problems are pretty basic. You just need to remember that the angle of elevation is from the bottom looking up. So now we're going to move on to an example using the angle of depression. Okay, so here's the angle of depression situation. It's another type of angle formed by a line of sight, except here an angle of depression looks down at something. Now the triangle that we draw is a little bit weird. It's formed by a normal line of sight, and you can see that here. There's the horizontal line, and then the line of sight is looking down. So we have two options with this triangle. First, we could make the triangle, finish it off here, and then use the height there. Or we can make the other triangle using, here in this case, the height of the lifeguard and the distance on the bottom of the water. But the angle that we would have to use is that angle there at the bottom. And if you remember from back in the day, since these two lines are parallel, those two angles are congruent. So really, it doesn't matter which one of these triangles that we're working with, but it does matter that we're using one of those two angles and not the other one, because that is not what we're looking for. So we could redraw that angle there at the bottom. So this is what the angle of depression is. It mentions here they're congruent because of alternate interior angles, and that's the truth. So now we're looking at example 5. We're going to math this thing, and then you can solve the rest on your own. Number 5 says a lifeguard is sitting on a platform looking down at a swimmer in the water. If the lifeguard's line of sight is 8 feet above the ground and the angle of depression to the swimmer is 18 degrees, how far away is the swimmer from the lifeguard? So let's draw a diagram here. Let's see, lifeguard in a chair. There's a chair. There's the lifeguard stand. Yeah, it's pretty awesome. Here we go. Lifeguard sitting in the chair. Yeah, he's having a great time. All right, we got some waves. Then we got a swimmer in the water. Stick your hands out of the water, swimmer. We want to see what you're up to. Okay, now we have a couple options here. So what I usually like to do, we need to connect that line of sight because we have the height here already. We have the distance with the water. I like to connect the line of sight from the lifeguard down there to make that triangle. But the angle of depression that we're talking about uses the horizontal distance up here, so we'll deal with that. So let's label what we know. The line of sight is 8 feet above the ground. So what I want to label here is 8 feet for how high the lifeguard is. And then since this says 18 degrees up there, I can also label 18 degrees down here. And I would rather use that as my focus angle. Makes things a little bit easier. And finally, it says how far away is the swimmer from the lifeguard. So I can put an X down here to determine that. From this point on, normal trig problem. We label the opposite side. That would be the 8 feet. The adjacent side. That was weird. The adjacent side is right there. And here's the hypotenuse that we're not going to use. And since we have O and H again, we're going to use the tangent ratio. 18 degrees, that equals 8 over x. And we already solved problems like this, so let's crank through this. Multiply both sides by x. X times the tangent of 18 degrees equals 8. We're going to divide by the tangent of 18. I'm running out of space. When we do that, we get x equals, pull up that calculator. What's up, Silverback? 8 divided by the tangent of 18. And that is 24.62 degrees. Now it says we're rounding to the nearest tenth, so 24.6 will be good enough. 24.6. Oh, that's not degrees. That would be feet. And that's the distance of the swimmer, and we're done. So this video talks about the angle of elevation and the angle of depression, setting problems up to solve. You have problems to finish on this page, so please do that. And then we have an assignment for you to complete after. If you need some help or you need to watch this video again to clarify some things, please do that. And as always, be good. I'm always watching.